Hey guys, Professor Doney back once again, and we're in the middle of talking about temperature. Okay, we're going to do a quick temperature problem here and just do a little bit of conversion. And what I'm doing right now is checking the current temperature. It's saying that it's 70 degrees Fahrenheit, so we're going to put that in here if I can. Let's see if I can get this to work. Temperature is 70 degrees Fahrenheit. Actually, that may be the high temperature today, which I don't think it's gotten to yet, but we can always hope. So that is obviously in Fahrenheit, so I'll put a little F there. Now, if we remember, temperature is a measure of the average internal kinetic energy, which is, kinetic energy, if you remember, is 1/2 mv squared. So the higher the temperature goes, the more kinetic energy internally average the material has, and the faster the molecules are moving. I guess you could think of it that way. So what we want to do is basically just convert this into degrees Celsius and into Kelvin, the absolute scale. Now if we go back and look at what we have for those equations, for Fahrenheit from Celsius we have 9/5 times Celsius plus 32, and if we're going from Fahrenheit to Celsius, minus 32, and then we have to put the 5/9 in there. Okay, and then Kelvin, the last one, is going to be degrees Celsius plus 273.15 or something like that. So those are our conversion equations. This is really just a plug and chug, as they say, kind of problem. Now just real quickly though, since I have 5 minutes here to do this problem, I want to talk about how they come up with these equations. If we took at the two scales, the centigrade scale or the Celsius scale and the Fahrenheit scale, and we look at their freezing points and their boiling points of water, and let's pick a different color here. Centigrade scale or Celsius scale is here at 0 for freezing. Maybe not. Hang on. I don't know why I picked black there. Makes it interesting. It's still black. Alrighty. Awesome. There we go. 0 Fahrenheit, 32, 100, 212. Okay. And that's based on the graduations when they did cylinder. Centigrade means centi or has centi in it, which is 1/100th. It's basically 100 graduations or levels. Here we actually have 180 graduations or levels. So if we look at these equations real quick here, the 32 is basically to get these to start at the same point. If we're looking at, we have to subtract 32 from Fahrenheit to get it to level up with C, and add 32 to the Celsius to get them to start at the same point. Also, if we look at the difference, this has 180 graduations, this has 100. If you take 180 over 100, you get the ratio of 9/5, which is we see here in that equation. We flip it, we get that, depending on which way we're going. So equations just don't come from nowhere. There's actually a basis. So let's get to our example. We're starting out with 70 degrees Fahrenheit, and we want to put it into degrees Celsius. So we're going to go to the second equation. Celsius is going to be 5/9, the Fahrenheit minus 32, and so we have Fahrenheit minus 5/9 times what, 70 minus 32. That's going to give us 5/9. What's that? 8, 40, 38. So 5 times 38 divided by 9 gives us 21 degrees. My wife would tell me that's a good temperature. She's from Europe, so she thinks and looks at temperatures that way. We go into Kelvin. Kelvin is just going to be centigrade plus 273. So if we add 273 to that, we get 294 Kelvin. Alright, and that's the absolute scale, scientist, all that. So real quick equation problem there, using the equations for temperature conversion. Nothing fancy. Pretty much plug and chug. So I hope that worked for you. We'll see you next video.